In this presentation, I would like to discuss about a roadmap to business analytics. Business analytics has become both a mantra used for attracting people as a term and excite people to come forward to apply business analytics. The mantra, in order that it is meaningful for decision making, we have to realize organizations have to leverage on some of the important tools and models that are used in business analytics. In what context, what models are used? This is always a question everybody asks. When I meet students for the capstone project, they go on saying that we don't know, you are saying regression, sometimes logistic regression, sometimes principal components, sometimes there is aggression that we have to use regression, but we are not able to understand. So to clarify things, I thought I should make an extempore type of a talk, which you can call it a presentation or a brief introduction to the landscape or the roadmap of the BA models. There are two types of learning that takes place in business analytics. One is what is called supervised learning. In supervised learning, I have a clear demarcation between y and x. Y is a function of x. That's what we say in a course, where y is a dependent variable, x is a set of independent or input variables, and the value y depends on x. I may have 5000 records of y and x. Then I will partition the data into training and testing. I will build a model for the training and then use it to test the model. This is how the supervised learning works. Now, if I say y is a function of x, I need to know what scales we use. Suppose y is a continuous number. X is also a continuous number. All x's. For example, y measures the number of units a new product I will be selling. X is a set of variables. One is my price, my competitor's price, the advertisement budget, and the disposable income. I have to predict y depending on all these variables. When both of them are continuous, I use what is called multiple regression analysis or multiple linear regression model. Y is a measurable variable such as demand. X is a set of input variables such as price of my product, my competitor's product, my disposable income or the consumer's disposable income, and advertisement budget. How I can predict the value of demand, the sales. This is an example of supervised learning. The first model we talk about is regression. Now, y is a continuous variable, but x is somewhat a categorical variable. Let's say, what is the meaning? I ask consumers to rate the brand, and let us say I say on a rating scale of 1 to 5, 1 means do not like it at all, 5 means like it a lot. Then I talk about the brands. Let's say Motorcar Tire, Dunlop, Seat, Goodyear, Power Cushion, MRF. Then they give some numerical rating. Supposing I say it is Seat Tire, they say, let's say the consumer gives a rating of 4. The moment I change it to MRF, the consumer may say 5 or 3. In other words, the right hand side is not a numerically oriented variable, But the left hand side continues to be a numerically oriented variable. I still need to predict the rating the consumer will give for a brand. Rating is a function of brand. In this case, I use what is called multiple regression with a dummy coding for the categorical variable, and hence it is called dummy regression model, which is very popular in studies like conjoint analysis. Consumers place importance on various attributes. These attributes may not be mathematically measurable, they are all discrete and categorical, but the consumer utility changes, and how it changes I need to capture. I use what is called conjoint analysis, which is an application of dummy regression model or a qualitative regression. Both the terms are used. Now, why the left hand side is categorical, let's say, and X is continuous? We have a problem. The target variable is a group variable. How do we do? Let us say I have to predict somebody will default on a loan or not. I have given loan, the bank has given loan. Will that person default on the loan? How do we find out? So the probability of default I will have to predict. So either the person is a defaulter of a loan or not. So my target variable is a grouping variable, and the right hand side is a continuous variable. I have two models available for this. One is the famous linear discriminant analysis discovered by Ronald Fisher, the father of statistics, where the left hand side is a grouping variable, right hand side is a set of continuous variables. The other one is I can use logistic regression model, where the same thing, left hand side is a grouping variable, right hand side is a continuous variable. In discriminant analysis, I am making certain assumptions. The right hand side variables have to be strictly continuous and multivariate normally distributed. In logistic regression, you do not have to make any assumption about the right hand side variables or the independent variables to be multivariate normally distributed. It is based on a principle of a sigmoid function, and it is focusing on measuring the odds and probabilities, and therefore it is very popular in the analytics world. But when you have got more than two groups, multiple discriminant analysis is much easier to use and interpret than the logistic regression. Both these methods are used to re-emphasize when the left hand side variable is a grouping variable, which we call a target variable. Is it a grouping variable? If it is a continuous variable, we know we can use regression. If it is a grouping variable, we choose between multiple discriminant analysis as one approach and logistic regression, which are traditional orthodox models where statistical hypotheses can be tested. We also have CART, Classification and Regression Tree, CART. The acronym stands for Classification and Regression Tree. So when the target variable is a grouping variable, I can use CART, which is a powerful technique today, and that does not have very neat statistical hypothesis, but it is based on a Gini type of index where I am able to get a much better predictive accuracy than the traditional models, CART. Another method which I use for the same scenario is neural network, artificial neural network or neural nets, which is also a powerful technique which can be used for predicting the target variable, which is a grouping variable, as a function of number of input variables. Example applications are predicting the credit risk default in marketing, whether a person will buy the product or not, in organizations and sales performance, whether the person will be a successful salesperson or not. All these things we can use neural network, CART, which are powerful techniques, and then we also have traditional wonderful techniques, discriminant analysis and logistic regression. There is another one which is random forest, where we grow lot of trees. Each tree is a classification tree, and then we select the best tree to predict the outcome of a target variable, which is a grouping variable. While discriminant analysis and logistic regressions have powerful explanatory power, which the executives can take advantage to interpret the results, in the case of neural network and random forest, we have the problem of the constant and continuous criticism of black box. Neural network universal approximation, it can predict very well, but it is a black box. In the sense, if the value of x increases by 1 unit, what happens to y, I cannot so easily say in a neural network. But if you are interested in predictive analytics, accuracy is paramount. Neural network and random forest will be very good. They are called also part of what is called machine learning. So neural network, random forest, CART, logistic regression, discriminant models, these are used when the target group variable is a grouping variable. This is the basic thing I would like to say on the roadmap. Then we have another thing. I am not interested so much in prediction. Y is a continuous variable, but X is a categorical variable, such as different brands, different price levels, low price, medium price, high price, and color of the tire is black or white, the sidewall color, and I want to predict the rating of the consumer for the brand. We said you can use dummy regression. But now my aim is not predicting the rating, but finding out whether the rating differs across the factors. In other words, y is a continuous variable, no doubt, my target variable, but my x is a set of factors, and my aim is testing the hypothesis. I use the classic technique called analysis of variance, discovered by Fisher again as part of design of experiments. Analysis of variance, analysis of covariance, these techniques I will use if my aim is differentiation of the groups in terms of the means levels. My standard hypothesis will be, do the groups produce different means? Are they statistically significant? The population means, are they statistically significant? There are three aims in segmentation. One is profiling, which is descriptive. The other one is differentiation. How can I differentiate the segments? The other one is classification. Can I predict? So when I don't want to predict, but I want to differentiate, I use analysis of variance as a technique. These are all under supervised learning. When I have a clear demarcation, there is a y which depends on x. So my entire data, I am very clear about y. I am very clear about a set of x which are input variables or independent variables. But life is not so simple. Sometimes I have only data. I don't know the outcome. I cannot say y, x and all that. I just look at data. So what you do in that case, I have only a data set. I have several columns. All those things are there. The outcome is not known to me. Then I look at data, discover pattern, trends and associations which I can leverage for better decision making. And one of the classic examples I can think of is called market basket analysis, where a retail market person can say, if somebody is buying bread, that person is also picking up a pack of Nescafe. He is also picking up a dozen eggs. He is also buying butter. So can I say that whenever this person buys bread, does the person also buy coffee? If so, what is the probability? If the probability is higher, I measure what is called the support for the item, the confidence level and the lift ratio, and then I maximize my revenue based on the minimum support and the confidence level, which I will fix as a threshold and then analyze the transactions, the famous market basket analysis. I just look at the data. I do not know the outcome, but I discover, oh, it's interesting. This is the association that exists. You look at the sites of Amazon.com or Flipkart. So the Amazon, you will always find those who bought this book also bought this book and all that. And then they try to find out the association probability. So market basket analysis is one, which is unsupervised learning. So in the unsupervised learning, I simply have a data set. Supposing you can also say the entire unsupervised learning today, instead of using the word data mining, I can say machine learning, a new terminology that is taking place. Then we may automate it. The outcome is unknown. Let us say I have a set of X variables and they are all continuous. Hypothetically, I am assuming, because any scale it can have. And then I have rows. The rows are the objects. Let's say I have 20 salespeople measured on 14 continuous variables, 15 continuous variables for a sales recruitment. Now, if these variables are correlated, I use what is called principal component analysis or factor analysis to reduce the number of variables to manageable dimensions. That is called factor analysis or principal component analysis. Once I reduce the variables to dimensions, then I look at the objects. Then can I put these dimensions in such a manner that all these objects I can cluster? That's clustering. The other way to look at it is the data set is available. I cluster the objects using the variables, using some Euclidean distance method such as k-means method, hierarchical clustering. There are several algorithms. But what is clustering? I don't know the outcome. I look at the data, then I form some clusters. So it is unsupervised. Once I have the clusters, I do a profiling and give name to the cluster. For example, this particular cluster is a price conscious cluster group. People are conscious of the price. This particular cluster is value oriented cluster. People don't mind paying, but they have to see value. This particular cluster is indifferent cluster. They don't care whatever the price, they will buy. Now, if you have three clusters, which I did not know, now I have discovered, this is the outcome. Now a new record comes, I have to predict the outcome, it becomes supervised. Then I use a technique such as multiple discriminant, logistic, multinomial logistic, whatever. In other words, it's possible in a complex world in which we are situated that most of the time we may have to do unsupervised learning, but the moment I describe the clustering, it leads to a supervised learning. Therefore, a journey of unsupervised to supervised is also possible. Clustering is unsupervised learning to start with. Principal component and factor analysis are unsupervised learning. Then neural network and random forest can also be used for unsupervised learning called machine learning, which is deep learning, and this is gaining lot of popularity where the computer model, when you program it, will determine the outcome and it will automatically predict without yourself having to intervene. Then it will automatically dynamically change the outcome as things change and keep predicting, which belongs, what I would say, the machine learning of this kind and automation, it belongs to, it is the future of business analytics. So random forest, neural network can also be unsupervised, support vector machine can be unsupervised, Multi-dimensional scaling is another thing where I have variables. I'll have to map them in a graph and find out, is there a vacant spot for entering the market, and can I have an opportunity to enter the market? What are my strengths vis-a-vis the competition? What is called in marketing a perceptual map. I may have an x-axis, the sportiness of the motor car, y-axis, the safety of the motor car, what brands can I map it, and when I start the exercise I have no idea. This is also unsupervised learning. So all these machine learning, if I can automate, which are unsupervised, in the process the computer model will start the journey of unsupervised, identify pattern, then it takes the outcome as a path of supervised learning and then predicts the outcome in a dynamic manner in the changing world, and including big data and all that. This will be the challenge, and this environment of big data offers lot of opportunities for unsupervised learning in the form of neural network, machine learning, algorithms such as clustering algorithms, algorithmic trading. All these things are unsupervised, and then the computer itself picks up the outcome and predicts it in the supervised way, which is not known to us, and the whole thing continuously happens. All that is needed is a human intervention of an outstanding algorithm and program, then computer does everything. But we should not think computer on its own without our intervention will do everything, as ultimately is the human ingenuity that is responsible. That is why it is called artificial intelligence and artificial neural network, and machine learning is part of the unsupervised learning to start with. And this is the whole roadmap. You have a supervised learning to give a summary. You have an unsupervised learning. In supervised learning, I know the dependent variable, I know the independent variables. Y is a function of x. Then I use multiple regression analysis when the scale on both sides is continuous. When one side, left hand side is continuous, right hand side is categorical, I use dummy regression, conjoint analysis type of studies. When the target variable is a grouping variable, I use the right hand side is a continuous, I use neural network, logistic regression, cart, discriminant analysis and other techniques. And one more thing I want to add under the supervised learning, logistic regression can use both left hand side and right hand side completely 100% categorical. It can deal with that. It is a remarkable strength of logistic regression. So all this supervised learning. Then I have unsupervised, market basket analysis, clustering algorithms, neural network, random forest, support vector machine, multi-dimensional scaling. All these things are unsupervised, and then I try to predict the outcome as part of the unsupervised learning. The machine itself does everything, automate the whole thing, which is the future of business analytics as things stands today.